So here we have a question called powers, and it goes, what can you say about the values of n that make 7 raised to the power of n plus 3 raised to the power of n a multiple of 10? Are there other pairs of integers between 1 and 10 which have similar properties? So I wasn't quite sure how to attempt this question. So the first thing I did was I thought I'd have a go at trial and improvement. So I made a table with different, I'm just going to move this question out of the way, with different values for n. So here I have n is equal to 1, 2, 3, 4, 5, 6, 7, if you can see the 7 there. And then I have 7n plus 7 to the power of n plus 3 to the power of n, and then when n is equal to 1 it gives you 10, when n is equal to 58, and so on. And one of the things that I noticed was that when n was an odd number, all the values were multiples of 10. So I thought I'd have another look at other positive integers that sum to 10 as well. So I looked at 6 and 4. So 6 raised to the power of n plus 4 raised to the power of n, when n is 1, obviously that's going to be 10. But interestingly, when n is 3, it's a multiple of 10. When n is 5, it's again a multiple of 10. And when n is 7, guess what? It's a multiple of 10 as well. And the same thing happens for 8 plus 2. So here we have when n is 1, when n is 520, no, when n is 3, it's 520, when n is 5, we have a multiple of 10 there, and when n is 7. And surprise, surprise, the same thing happens when when we do 9 plus 1 as well. So we have 10 here, there, there, there. And when we have 5 plus 5, well, this is a special value because it's the same number. So actually all of these are multiples of 10. But so that includes odd numbers and even numbers, but 5 is a special case. So my conclusion is that when you add, so two numbers that sum to give you 10, when they're raised to a power, of the same power, if it's an odd number, it will give you a multiple of 10. And I have investigated this further, and I've found that any two numbers that sum together to give you another, so any positive integer that sum together, the sum of their number, when it's raised to an odd number, it will always be a multiple of that number. And I did that using simultaneous equation. So I did that using simultaneous equations where I had two equations and I rearranged one of them and then substitute that into the other ones, and then I used binomial expansion to have a look at this. What's this now? It's I guess it's a binomial form here. So this is the binomial form, and then I used binomial expansion to have a look at that. And I did find that this section of the equation would give you a multiple of 10, but this goes outside the scope of this video, so you'll have to see my next video for the proof of this. Thank you.